have so many problems and I can't figure them out.
Honey, it's okay. Why don't you talk about them to a group of people who are also struggling? Maybe it will help you feel better.
Okay. Hi, is this Calculus Anonymous?
Yes, it is.
Great.
Good afternoon, everyone. My name is Integral, and I'm in charge of our meeting today. Let's begin by going around and introducing yourselves and telling everyone a little bit about your problems. Why don't you start?
Hi, I'm Derivative.
Hi, Derivative.
Hi, everybody.
Well, I'm having difficulty with the quotient rule. I've got the product rule down, but I just don't understand how to differentiate when the function is a fraction.
Thank you for sharing. Next, please.
Hey, I'm Polar.
Hi,
Polar.
I understand how to convert rectangular to polar coordinates. I know x equal r cosine theta, y equal r sine theta, r squared equal y squared plus x squared, and tangent theta equal y over x. But what I'm really struggling with is how to find the area inside of a polar graph. That just doesn't make any sense.
Hey, Derivative, we don't laugh at people's problems here.
Oh, okay. Sorry.
Hi everyone, I'm Volume. I know y'all think volume is easy, but finding the volumes of cubes and cones isn't my issue. What I don't understand is how to find the volume of a figure revolving around an axis. I think you use something called the disk method, but I keep forgetting the formula.
Thanks for sharing.
Hello, I'm Taylor Series. Maclaurin Series has it easy. He's centered around 0, but my center keeps changing. One moment, c equals 3, the next, it's 1.5. I'm so confused.
Hi, my name is Extrema. My problem is that there are so many ways to find maximums and minimums that I don't know which one to use. First derivative test, second derivative test, candidates test. Which one do I use? And what's the difference between relative and absolute?
Hi everyone, I'm Limit.
Hi, Lemon.
I'm pretty comfortable with general limits to 0, but when both the top and the bottom of the limits fraction are 0 or infinity, I get all confused. It's so frustrating and I'm so mixed up.
Thank you for sharing. I'll finish us off. My name is Integral. With so many different types of integrals, my head is spinning, but I'm especially troubled by integrals that involve partial fractions. How do you solve them? I think you do some special decomposition trick, but I just can't figure it out. It's driving me crazy. All right, everyone, are you ready to conquer your fears? Great. Okay, Polar, you're up first. We're going to show you a trick to finding the area inside those polar curves.
Okay.
Perfect. Gather around, y'all. Who would like to demonstrate?
I will. I may be confused on volume, but area is one thing I got. When you have two polar curves, the first step to finding the area between is finding where the equations intersect. Set the equations equal to each other and solve for theta.
Hey, I know how to do that. I've been solving equations since algebra.
Next, recall the formula for the area of a polar graph. Half the integral of the polar equation squared. The bounds are the theta values you solved for. Simple. And don't forget to add or subtract the area of the slivers on the sides if needed.
Wow, who knew it was so easy? Thank you, Volume.
No problem. But can someone please help me with the disk method? I can't stop stressing over it.
I've got your back, Volume. All you need to do is memorize the formula. Around a horizontal axis, it's pi times the integral of the equation in terms of x squared with the bounds as the x values. Around a vertical axis, it's pi times the integral of the equation in terms of y squared with the bounds as the y values. Just remember, horizontal equals x, vertical axis equals y.
Thank you. Now it all makes sense.
I need someone to explain partial fraction integration. It's giving me major issues.
I'll try. When integrating a fraction, if the exponential degree of the denominator is larger than that of the numerator, you must divide. Let me draw it out for you. Factor the denominator. Then set the fraction equal to a over the first factor, b over the second, etc. If the factor is quadratic, ax plus b will go on top. Then multiply the denominator and solve for the alphabetical variables. Plug those values back in and you're ready to integrate.
Wonderful. Who's next?
I guess I am.
I'd be happy to help you, Limit. If the limit to 0 of a fraction's numerator and denominator are both 0 or infinity, You don't have to think twice. Just use the L'Hopital rule. Take the derivative of both the numerator and denominator and recalculate the limit.
Thank you so much. That was so helpful.
Could someone please help me? Max and mins are driving me crazy.
I'd be happy to. The first and second derivative tests are used to determine relative extrema, while the candidates test is used for absolute. They are both used to find maximums and minimums. The difference is that relative extrema are on the open interval, while absolute extrema are on the closed. The candidates test involves finding the first derivatives to discover the critical values, which are the x values when the derivative is 0 or undefined. Then these numbers and the endpoints are plugged into the original equation. The highest y value is the max, and the lowest is the min, just like that.
And the first derivative test is just as doable. Use the first derivative again and find the critical values. Then, using these values, analyze the first derivative to the left and right at the points. If it changes from positive to negative, there is a maximum. If it changes from negative to positive, there's a minimum.
The second derivative test is similar. Use the same technique to find the critical values, then calculate the second derivative at the various points. If it's positive, there's a local minimum. If it's negative, there's a local maximum. If it's 0, well, the test fails.
Thank you so much, y'all. I feel better already.
I'm still puzzled on the quotient rule. How is it different from the product rule?
Ooh, I know, they are very much alike, but the quotient rule goes like this. FG minus FG, first things first, second things second, divided by g squared.
Wow, thanks.
Thank you everyone for coming to Calculus Anonymous. I hope talking about your problems really helped you understand them and increase your love for calculus. Remember, calculus rocks!
Yeah!